Well, welcome to week one, Introduction to Business Analytics. There is another video that kind of goes over the syllabus and Web Campus just to get you oriented to that a little bit. But this class or this lecture just goes into the basics of business analytics and why we should study it. So let's get started. There's a bunch of different quotes about data, but this one is one of the two or three of my favorite ones. Without big data, you're blind and deaf in the middle of the freeway. And companies that don't understand the data or don't understand what they're doing often make bad mistakes repeatedly. And they can't succeed and they don't move forward. And they say data is the new gold, and it's very true. But it's not just data, it's actually being able to derive knowledge from that data. So, like I said, there's another video that goes over the kind of the review of the syllabus. So we're going to go into that. So before we go into too much, a little bit about me. I'm not a PhD, so you can just call me Richard or Professor. I am a full-time student here at UNLV. I'm studying computational neuroscience. I'm also a full-time employee at United Health Group, or Optum. So you might see me around town as Southwest Medical. I'm a full-time senior data scientist or ML engineer. I graduated from UNLV with a Master's of Data Analytics. I think I was one of the first graduates there. I also graduated from UNLV, magna cum laude, in psychology with a minor in information technology, a minor in neuroscience, and it's called an honors degree, but it's a creative research Latin thing. My PhD, I study ways to help Parkinson's patients without drugs. In my work, I find ways to take data using machine learning and derive value and derive money from that. So I'm either directly helping patients and saving money, or I'm finding ways to make patient experience better while saving money. I've been at Optum for 4 years, 5 years, something like that. I've been at UNLV for 10 years. At my job at Optum, I do all types of different types of machine learning, Python, Excel, SQL. I do a lot of different things. I have a book that I'm a technical author on data engineering. I've included my LinkedIn, and even though my GitHub's a little old, it's there. I have a patent on basically readmission rates using machine learning. I've also taught in the College of Business before. I've taught business intelligence, which this class is kind of a watered down version of that, and taught for the graduate students. So I'm just kind of taking some of those lectures and providing you that information, because I think at a graduate level, when you say business intelligence, that's just the next step on beyond data analytics or business analytics. So if I can kind of prep you for that, I think it will help you in the business world. I taught Intro to Telecommunications, A+, Cisco, Big Data. Last semester, I just finished up teaching the graduate students Big Data. So that's a little bit about me. I love camping. I love getting out in nature. I don't have time as much as I'd like to, but I was camping at Mount Charleston 2 weeks ago. So I have a little poodle. Sometimes he might come up on video. His name's Lucky. You'll see pictures of him through the class. And I'll post more on the discussion. So for me, one of the things I really love about this is, somehow people say, if you go to the office, it's going to be the same job day in and day out. For me, it's not. Every day I get to research new problems and new solutions, and I get to use my head. For me, one of the worst jobs would be to do the same thing over and over again in the physical world. Go out and do this and go out and do that. That just doesn't sound like fun. I get to figure out problems in my head, then apply them. Another thing, it's related to that, I kind of like interrogating wives' tales or urban legends. There's a lot of misinformation in the world, and sometimes it's fun to say, hey, we can just know that that's not true, or at least we can derive that 90% it's not true. So that's one of the things I really do love. I love solving problems. I love interrogating. I love looking into a problem and figuring out what is solvable, what's not, what's true, what's false, and kind of going from there. So real quick, it's always hard to figure out why to go to college. I mean, it really is. And since I teach this class much more like a business class, like you're my coworkers, and not like I'm your professor, I kind of approach things differently. If you watch the syllabus video, I kind of go into that a little bit more, but I'm not a big fan of testing, because out in the real world, You know, at my job site, I don't get tests. Okay, so to give you a bunch of tests to prepare you for the business world, or to prepare you for the real world, it's just not. It doesn't make sense to me. But I want you to walk away with skills that do make you ready for the real world. I want you to walk away with skills that you can get a job and make money. So I was speaking at a conference, and they had this reporter from the New York Times, Washington Post, somewhere, and he talks about how college degrees have value. And there's a couple things I want to share with you real quick. And this next slide I just love. So this is if you have a major plus a data analytics certification, a few classes, something else in addition to it. Now, basically this class with something else. So my grandfather had a history degree. Okay, so right here, history. So if you have a history degree plus some type of data analytics certification, because remember, it says major plus specialized skill. You know, it could just be, like I said, a certification. It could be just a few classes. So if you have a history major plus a data analytics certification or skill, you're making 36% more. So if you make $100,000 as a history major, you're now making almost $140,000. That's like $40,000 more, a little less than $36,000 more. It's a lot of money just for a few classes, just for what I'm teaching you. Now, why is that? Why is it so important? If, you know, I know some of you are probably business majors, marketing majors, things like that. You're making another 33% just on this course and learning these type of skills. Why is that? A lot of what it is because data is what businesses operate on. And while you may have domain specialty, being able to extract information, or at least understand information from a data perspective is valuable. If you were to run a museum, you didn't know how the cash registers work, you didn't know, how like linear regression worked, you didn't know how the actual business of running a museum worked, it would be really hard to run that museum. But if you take a few data analytics classes and say, hey, look, here's a cluster of school kids that we get at 2 o'clock, so we know we should have X, Y, and Z. We know on the weekends we get this type of cluster of customers, well, you can run that museum better. And that's basically what a lot of this class teaches you. There's a lot of talent shortage. I'm not going to go into this slide because it's horrible, but just about 2 weeks ago, I read on, I think it was LinkedIn or Glassdoor, the 2 most desirable skills are Excel and SQL. Both things I'm going to teach you. This class is mostly Excel, but I'm going to go over SQL because I think it's important that you learn SQL. SQL, structured query language, is how do you pull your own data. Okay. This is one I found a couple days ago. I haven't had time to verify if it's true or not, so this could be complete BS. But let's just assume it's relatively true. The return on investment, look at that, second highest one is IS, Information Services, basically this class. Okay, and so you're in a field that employers want to hire you from because it's that vital. Okay, so this class is not a waste of your time. This class would transfer to real world skills. I'm not here, and here's an important part, I'm not here to teach you everything. I'm here as your co-pilot. I'm here to unblock and unconfuse things. But there's a book, you read it, you learn it. If you have problems, I'm here to help. Just like in the job world. I can't go to my boss and be like, hey, can you explain this to me? I have to try to figure it out myself. If that doesn't work, I have to go to ChatGPT, or I have to go to Wikipedia or LinkedIn Learning, try to learn it that way. And then if I still have problems, then I can find an expert that says, hey, this is where I don't understand this concept. Can you help me? But I don't go right directly to my boss and say, hey, dude, I have no idea what this ridge regression is. I have to do a little bit of the legwork myself. And that's kind of what I expect of you too. Because again, I teach this much like a business class. So hopefully either after this seminar or after this lecture, you can watch the syllabus demo. So just real quick, in every module, I put the reading in there. We're only going to go up to chapter 11. Okay, so we're going to cover these first 11 chapters. We're going to cover them in order. So week 1, this. Week 2, this. Week 3, that. Couldn't get much simpler. Each one of these chapters, for the most part, except for time series, has demos and Excel work that you have to do online through MindTap. Okay. Now, business intelligence at the end of the day is taking all this raw data that businesses collect, that we collect, and finding a way to monetize it, finding a way to get knowledge out of it. Okay? And it may sound really simple at first, but it's not, because data can be messy, data can be have bad data in it, it can be incorrect, and all of that. There could be different ways to interpret the data. You could give the same data to 2 or 3 analysts, and they come up with 2 or 3 different answers. Okay, so the process of business intelligence is kind of going from, like I said, that raw data to some type of either knowledge, outcome, or prediction. Okay, you're taking data and moving it up the ladder. And this is kind of, they call this a data science process. I'm not really sure that's the most adequate term, but how do I increase sales of product X for next year? Well, I get the data. Here's the sales. Here's what's changed. I explore the data. This is the analyze homework, the analyze me homework. I model the data. Well, if I have this and this happened, well, maybe if I change this, I'll get more of that. And then communicate and visualize the results. This is kind of the core of how I teach a class. Is this kind of whole method right here. I can either give you the data, or you can get the data. You're going to analyze me the data, and then you're going to communicate it with the teach back at the end of the semester. And it's a rinse and repeat type of process. So this is kind of what I was talking about. We have raw data, events, emails, images. Maybe customers are emailing you, hey, I'm unhappy with this product. Then we have to figure out why they're unhappy. And we have to figure out kind of more specifically what we can do about it, or how it's affecting your sales, then what we're going to do about it, and then change it and start again. It's like I said, this is just a little bit more simplified process of the last slide. Now, the next slide kind of goes to this, but goes over time. Okay, so let's think about this for a second here. And we have reporting, which is just, hey, last semester I had 18 students. It's just a raw number. And analysis is, last semester I had 18 students. I don't know, all of them, unless they got A's. Monitoring would be, hey, the last 3 semesters I had 18 students, 17 students, and 19 students. And so I kind of look at it more linearly. I put a dashboard, they call it KPI, or, there's a ton of different terms for it. Basically, you're monitoring the change you've made. Okay, you can report on something, your grades. You can analyze it. Hey, this is what I need to graduate. And you pull your transcript. Hey, this is where I'm at right now. And then these are the classes I need to graduate. So that's the basics of Power BI. Or just BI, sorry. It can enhance operational efficiency. So business intelligence can allow us to figure out, like in marketing, particularly how we can spend our money the best way possible to get the most return on our interest, the most bang for our buck. Okay. Are we trying to save money? Are we trying to optimize a certain type of customer? Where are we making our most money? How can we make things easier? How can we and the next one is, how can we get a competitive edge? And this was going back to that quote. If I have better data, or at least if I can monetize my data better, or at least understand it better, then I have a competitive edge. We look at maybe pizza places, and Domino's, Pizza Hut, things like this. Well, maybe, Domino's figures out ways to get locations closer to areas that order more pizza. And they do that by analyzing and buying basically data from third parties and say, hey, if you look at this area, this is where it's really popular, it's where a lot of pizza happens, so let's put a location in here. But they also might have to consider like retail costs, and safety and a lot of other factors. But if they can figure out a way to find a better place to put pizza places, they can get a competitive edge over Pizza Hut. Also uncover new opportunities. We look at, particularly in the drug market, There's a lot of molecules, right, since I'm in healthcare, that haven't really been used to cure cancer, cure colds, things like this. But we know the effects of these drugs. So how can we take these unused molecules and apply them and help people? Okay, and it's not just that; it's multiple different things. How can we lay out a store to maximize income? How can we run coupons that will inspire people to buy things? You know, how can we start a recycling program that people will actually use? Now, there's a lot of different terms, and especially in job postings and stuff like this, there's a couple big ones. Now, I didn't put the data science there, but business intelligence versus data analytics. Data analytics, at the bottom level, you're basically just doing the analytics and doing the predictions. And business intelligence, you're taking that information and trying to drive it home. You're trying to visualize it. You're trying to convert that data into intelligence. Okay? So data intelligence may be just somebody sitting in the classroom taking notes, just trying to figure out what's going to be on the exam. Business intelligence is rewriting those notes saying, hey, the teacher said this is really important, it's going to be on the exam. Last year's exam had this year's exam might have this too. I mean, it's going, taking your notes and just reorganizing them, trying to really figure out what is going to be impactful for the business. Data analytics, you're taking that raw data and trying to summarize it or trying to predict. Business intelligence, you're trying to take that prediction and try to make change or drive change in the business. So again, nothing here really is earth-shattering, but let's go to topic, I think 2 is next after this. Okay, I don't know if you have any mind tap work this week, I'll have to look, but you do have a discussion, a little introduction discussion. Okay, so some tools you might need, and you might not need, is Tableau and Power BI. Those are 2 tools. Both of them are free. If you're on a Mac, I don't think Power BI works on a Mac. Tableau works on either one. I'm going to ask you to do a couple visualizations in this class towards the end. You can use either program. If you're good at Excel, you can use Excel. Again, I'm basically technology agnostic. I don't care what tools you use. As long as you give me a visualization, I'm happy. There's websites that can do this. ChatGPT can do this. You know, so I need a couple visualization. Google Colab, we might do some light assignments when we get to SQL on that. Basically, that is just a computer on the internet. So I can give you some code that you can practice SQL on. It's the only time we'd use it is that SQL lecture. And then basically you can pull data, you can kind of change the data a little bit, and download it to Excel. I'm trying to figure out if I want you to do it actually in Excel or I want you to do it outside of Excel. Word and Office does help in this class. Excel, I just like using it. I don't like using the MindTap's online interface. I just like looking at the data and just doing it myself in Excel. But MindTap does have Excel. If you have Excel, that's great. Some of the formulas won't work in Google Sheets, I don't think. I've tried a couple. Some of them do, some of them don't. For the reports, you can use Word or Keynote or Google Documents. I don't care. So there's all that. Some additional things, I'm going to probably do a demo on Alteryx. A lot of students seem to like that. That's more, a lot of the financial firms and a lot of the accounting firms tend to use that. That's the book I was a technical editor of. The book I wrote about was ETL, but I know that most of the big accounting firms are really looking for Alteryx people. So if you're interested in accounting, forensics accounting, or I don't know, any type of accounting, Alteryx is a program you should definitely learn. I'll probably do a demo, like I said, of Alteryx. And again, if you can, it doesn't have to be paid. Sign up for ChatGPT or Claude or BART, or Copilot on, I think it's called Copilot in Windows. Any type of LLM that you can use to ask questions, interact. Some are better, some are worse. I really don't care what one you use. It just helps when you're trying to solve a problem or trying to gain knowledge to have a good LLM. Now, I did I don't know, last year sometime when I was teaching last year, I did take a Google Business Intelligence course, knocked it out in like a week. Uh, I don't know if I'd really recommend that certification. It's not that bad. It's not that great. It's just, you know, it's a medium certificate. It looks good, I guess, on your resume, but I don't think I learned a whole lot. LinkedIn Learning, though, has a lot of great resources. If you're having problems, hey, I don't understand a pivot table, I don't understand a pivot chart, I don't understand this, LinkedIn Learning is a really great place to learn a lot of this stuff at. As a UNLV student, you should have LinkedIn Learning for free, and there's more than just Excel. I mean, Tableau, Power BI, statistics, writing, I mean, just a ton of stuff is all in LinkedIn Learning. So if you have questions about anything in this class or other classes, as long as your teacher will allow you to use it, I really recommend looking into LinkedIn Learning. I have some on the course homepage. I have some other places you can get extra material if you need it. So I just want to cover one of the big data ideas, because basically I can tell you what happened. So let's say 20 years ago, all these companies said, hey, big data is going to change the world, big data is going to do all this, big data is going to make a big impact. And so a lot of these companies started collecting all types of big data. And you know, it does make a big difference. It does help a lot to have a lot of data. The problem is it wasn't until like the last 5 years that we've really been able to, maybe not in the last 3 years, we've really been able to interrogate, understand, and predict using that big data. Okay, so for 15 years maybe we collected big data, but we haven't really understood what it means. How do we derive knowledge? How do we move forward on it? So big data can be a lot of different things. You know, things like Facebook, Twitter, Instagram. I mean, you'd be surprised at all the different things they collect. Time on page, sites you went to, referring sites, exit sites. I mean, all types of information. The Internet of Things, such as your watch. You know, I have an article on an ethics class I do, where people that were running, military people were running, and they had a smartwatch, and it revealed the location of secret military bases. Okay, because smart connected devices like smartwatches, a lot of times will track your GPS. Okay, Nissan tries to infer what gender the driver is by how the person drives and sells that information. Okay, every business transaction, every phone call, a lot of the stuff is all recorded somehow. And since it's recorded, they try to figure out ways to help the customer experience and make money at the same time. Public records, there's a ton of stuff at both our local government and the U.S. government in terms of data. There's a ton. Scientific research, healthcare, things like that. So, you know, one of the things that I talk about in another class, which is crazy, when I taught the big data foundations, that whole book that I used to teach with was 12 megs, and it took probably at least 6 months to write, and countless people to create it. Okay, so maybe it was, I don't know, 100 megs out the door. I mean, with all the editing and going back and forth with authors. I mean, I've written books before. It's a lot of work. So 6 months. I don't know, let's say 10 years ago to write a book, that's 12 megs. Now I take a picture of my poodle Lucky, and in the raw format, it's 58 megs. I mean, what's that, 4 times the size of the book? It took me 1/10 of a second to create that image. I mean, it's just the amount of data that we're collecting, it's just expanding and blowing up, and just, I mean, it's more than exponential growth. Okay. We're creating more information now every month in the whole history of like the human history. I don't know, I think in like 2012, there's a study that says, hey, we're creating more information every month now than we did for the whole history of, you know, for the first 2,000 years of recorded history. And this is part of why. I mean, you just take a picture and boom, you get more information in one picture than you did, you know, somebody spending 6 months to write a book. Now, and we look at it, and you kind of see that growth right here, you know. And I don't know if I really call it the beginning of the digital information age, but, you know, you had a VHS tape that would hold, I don't know, I guess one movie. Now, like my MP3 drives or my little, you know, thumb drives, I can put 10 movies on there. And I mean, with a VHS tape, it's not like you can send it to somebody. I mean, you'd have to mail it. But if I email you a movie or a video, it just it doubles that data. Same thing with music. If I download a song, try and kind of remix it a little bit, well, it just doubled that. Where you couldn't do that 15 years ago. So that is part of the whole digital explosion, and it's much, much, much bigger than this. I mean, this graph does not do it justice. This is kind of what I talked about. This is a little bit better layout. That's why I kind of put it here. The way the book is laid out, the way that BI with the kind of triangles and everything else, this is kind of the way I talked about it. So we have raw data, which is descriptive analytics. This kind of information. What's the average age of the students in my class? Okay. Diagnostic, why did it happen? You know, what will happen? Predictive analytics. This is where a lot of the business stuff floats in right here. Predictive analytics and prescriptive analytics. So that's kind of, you know, the first 2 to maybe 3 is more the data analytics domain. The last 2, prescriptive analytics and predictive analytics, those are more the business intelligence. We're going to kind of cover them all, focusing on the first 3 primarily. But prescriptive analytics is the idea how, you know, with machine learning or other tools, you know, how can I make this happen again? So predictive analytics is, okay, I got an A in this class and I studied for 10 hours a week. I studied for, 8 hours in this class, got a B. That's predictive analytics. This is kind of the difference. This one doesn't go into business intelligence, but business intelligence would float between reporting summarization and kind of interpretation. So it would be right between kind of here. So you have kind of data analysts, sometimes they call them DBAs, but people that basically clean and hold the data. You have an analyst that kind of does basic statistics. Then you have a BI guy that will float in between here. You have a data scientist that kind of does the whole thing. He does more experiments, or she does more experiments. You read this. It's just same. Okay, prescriptive and predictive analytics. Predictive analytics is used to make informed guesses about future events based on historical data. How do we do that? We do that with statistics. This involves statistical models, machine learning, data mining, algorithms to analyze current and historical facts. You have to make sure the facts are accurate, otherwise you're making an incorrect prediction. An example of predictive analytics is a retail company using customer purchasing history and demographical information to predict future buying behaviors and trends. This can help in planning inventory and market strategies. Now, prescriptive analytics goes a step further by not only predicting future trends, but also suggesting actions and outcomes. It helps decision making by prescribing a set of actions to achieve desired outcomes. And let's just go to the example. A good example of prescriptive analytics is a logistic company optimizing delivery routes, either like based on weather or based on traffic patterns. The analytics system not only predicts traffic patterns and delivery times, but also prescribes the best route for drivers to minimize delivery times. And this shows you it's kind of a messy chart, but just all the things that can go into actually delivering information. So we have raw data. It could be cash registers. It could be GPS from a vehicle. We ingest it. We put it in a data lake, a place that just holds it. Then we kind of figure out how to clean it, or at least get it in there in a standardized format. You know, maybe some cars report in kilometers per hour. Some report in miles per hour. We figure out what's important, and we kind of develop a model to say, hey, this is what I'm looking for. We kind of deploy it, we serve it, we fix it, and we eventually give it to our shareholders or leadership or whoever requests it. We went over this a little bit. This is a little bit more in detail. I'm not going to go over this again because, again, I want you to learn kind of both sides of this. Because some people prefer the data analytics, some people prefer the business intelligence. Some people like doing graphs more and want to kind of stay away from the statistics. Some people want to do the data and the statistics and the interrogation more and want to stay away from presenting in meetings. So again, my past role pretty much was a data scientist. Data scientists are people that kind of run experiments on data, try to figure out what works, what doesn't work at the end of the day. And this kind of breaks it apart between business intelligence, which isn't really necessarily run experiments. They're trying to figure out ways to use prescriptive intelligence or prescriptive reporting to make better decisions, where data scientists are trying to find ways to, I guess, look for patterns that might not be readily apparent. Yes, that's fine. Your book talks about, I think, the 3 or 4 V's. I'm not sure what one the book talks about, but it's kind of a BS term because there's like 20 V's. And all it is just when we look at data, how do we look at it? Okay. I'm trying to think if your book uses 3, 4, 5. I mean, I have a chart somewhere with 27 V's. It's just one of those nebulous terms, but I just kind of want to give you a general idea of what they are. So, velocity. So how fast are you getting the data? For example, if you're getting car data, and not necessarily speed, I'm not worried about that, but are you getting it every second? When I work on some of the stuff for UNLV for the brain-derived information, we're sampling at 20,000 samples a second. So we're getting a lot of data. When I work with claims data at work, we're getting data every 3 months, much slower. So what type of velocity are you getting? Also, how much of it are you getting? Are you getting just a few megs? Something that would fit in a flash drive? Are you getting something that is just terabytes? It takes hours to download. What does the data look like? Is it structured? Like, is it in Excel? Is it unstructured? Is it a picture? Okay. To me, these are the big important ones, and also value, but that's not on here. That's, I think, on another slide. How fast are you getting it? How much of it are you getting? And what's the variety? Because velocity and volume are a lot easier to handle if there's no variety in the data. If you're getting just GPS coordinates and you're getting a ton of GPS coordinates, that's not a problem. But if you're getting GPS coordinates sometimes and then it's mixed in with some pictures, and it's mixed up, it becomes a much bigger problem. See, here's a 4 of these. 5 V's. This one has value. I mean, if the data you're getting has a lot of value to the company, that has a lot larger impact on volume, velocity, variety, because the business is want to do something with that sooner. If it's just secondary data, something that maybe nobody necessarily cares about right now, every company runs NPS scores, which are like scores that say, hey, how good we do, but we only report them out, I think, like once a year. It doesn't really matter because nobody's going to look at it for, 3 months. So what value is that? But if we're looking at payments, like credit card payments, it has a lot of value. If there's a problem with receiving our credit card payments or credit card payments stop, there's a lot of value in knowing that information. Hey, look, we're getting 1,000 credit card transactions a minute. Oh, all of a sudden we're getting 0. Something's wrong. So, big 6. This is kind of what, this is one of the big takeaways. Data we've been collecting, data is just this raw, the age of everyone in the class. The grades you've gotten in every class. It doesn't have a lot of value. I mean, when you get a job, the grades you have in your class, they don't matter. How many, what's the air intake of your vehicle? It doesn't have a lot of information. It doesn't have a lot of value. Now, information adds context to that. Well, if I know the classes, hey, you took the business intelligence and you got a B, and you took art and you got an A, we start adding information to that. Okay, knowledge, we take that information that we have and we can kind of make a judgment on it. Well, if I got an A in the last 3 art classes I took, and I got C's in all my math classes, maybe I should be a math major. It's an idea. If I want to become a doctor, a medical doctor, and I suck at biology, that's wisdom. That's when you take kind of that information and derive knowledge. Yeah, I'm not doing good in any of my biology classes. I don't like biology. I don't like chemistry. Why do I want to become a doctor, a medical doctor? That's the wisdom. Wisdom applies knowledge to make sound judgment and decisions, or even changes, I would say. So this, you can screenshot this. This is one of the vital concepts. This is what all data analytics and business intelligence, data science, this is what companies are looking for. Methods go from the bottom to the top. This is where all the money comes in. It's going from that data, that raw data we're collecting, going up to the top. And there's a million different ways to do it and a million different problems along the way. This is a little bit more detailed one. I like the last one a little bit. This is from one of the books I taught. It has the same basic information, but if we can get up to wisdom, we can make a judgment. If we make a judgment, then we can take action. And if we take action, we can make an experience. So if I offer a 15% coupon this year on Black Friday instead of the standard 10%, am I going to get more money and new customers? And am I going to make more money in 2025? Or am I going to lose more money? So I know that, hey, last year, maybe, or 2 years ago, I offered 5%, I went to 10%, and I made a lot more money, even though I'm losing 5%, but I'm making a lot more money because I have a lot of new customers, and they reorder from me. Hey, maybe this year I'll try going to 15%, that's my judgment, and I'm going to apply all these coupons at 15%, that's my action, I'm going to start tracking it, that's my experience, the result. What happened in December? Did I make more money in 2025? Was that a good thing or a bad thing? And you see it's kind of cyclic. The goal is to turn data into information and information into wisdom or insight. Who's buying our servers? Who's not buying our servers? Is a Chromebook a good thing to buy? It's a bad thing. What do customers want? What do customers not want? What are customers willing to pay for? So that's all I have. Please remember to do the discussion this week. Please remember to do any MindTap work. Sign up for MindTap. Get it all squared away. MindTap does have office hours if you have problems. Just go to their office hours. There's a link in the module. It's not even module 1. It's the very top module. And please make sure to watch the syllabus video. And please make sure to take the syllabus quiz. Any questions, email me or text me. Thank you very much.